Sequences. Consider the sequence 5, 9, 13, 17. In this, un equals 4n plus 1, or n is greater than or equal to 1 for all natural numbers. Un is our way of writing down what the general term is. That is the nth term to most people. But it's the general term. It could be the first, second, third, whatever number we want to put in for n. It represents that term. All we do is substitute the n. We'll have a look at an example here. Write down the first 3 terms and the 10th term of the sequence given by un equals 3n minus 2. That's for all natural numbers for n greater than or equal to 1. Here we work out that u1 equals 3 times 1 take away 2, which is 1. u2 is 3 times 2 take away 2, which is 4. u3 is 3 times 3, 9, take away 2, 7. And u10 is 3 times 10, take away 2, which is 28. Another example, find un for 8, 14, 20, 26, and so on. Here we can see that our difference between our terms is 6. So we've seen that we could write that in the form un equals 6n. Then all we have to do is consider what we do to the first term when n equals 1. We get 6 times 1. What we'd need to do to that is add on 2. So we get 6n plus 2. Find un for 1, 4, 9, 16, and so on. This sequence should be familiar to us. These are just the square numbers. 1 squared, 2 squared, 3 squared, 4 squared. So it's 1 times 1, 2 times 2, 3 times 3, 4 times 4. So our general term un equals n squared. Another thing that we need to look at is iterative formulae. They're also called recurrence relations or term-by-term rules. Now, a recurrence relation is when a sequence where each successive term is found from the previous term. So you're using the last term or terms to generate the next one. An example of this, un plus 1, so that's all in the subscript, un plus 1 equals un plus 3. Gives us the first term u1 equals 5, and it asks us to find the first 3 terms. In this case, u1 is 5, it gives us that. u2 is u1 plus 3, because the next term is generated by the last term plus 3. So that's 5 plus 3, which is 8. u3 is u2 plus 3, which is 8 plus 3, which is 11. We're also going to look at convergent and divergent, and what them two things mean. Now, convergent sequences get closer to a limit as n tends towards infinity. That means that if we stick in really large values of n, our sequence is getting closer and closer to the same number. A divergent sequence gets larger as n tends to infinity. What I mean by that is it could either get more positive or more negative, but it'll go towards either infinity or minus infinity. Look at an example. un equals 2 to the minus n. You start sticking in large values of n is 10, you get 1 over 1024, and big values of n will tend it closer and closer to 0, so that's convergent. Another example, un equals 3n plus 1. You stick in big values of n, 1000, you get 3001, 10,000, 30,001. So that's just getting larger and larger, so that's divergent. If a sequence doesn't get closer and closer to the same point, or get bigger and bigger and bigger, it could be periodic. Now that's a sequence which runs in a pattern of values. The period is how long before it starts to repeat itself again. So how many terms there is before it repeats. An example of a periodic sequence would be un equals 5 plus minus 1 to the power n. Now if we look at how this works, if we stick in for the first term, it's going to be 5 plus minus 1. The second term is going to be 5 plus minus 1 squared, which is 5 plus 1. Third term becomes minus 1 again. Fourth term becomes plus 1 again. So we get 4, 6, 4, 6. And it's going to repeat this pattern again and again and again. That's only got 2 terms before it repeats, the 4 and the 6, the 4 and the 6. So it's got a period of 2. Thank you.